Good morning, students. It's nice to virtually see all of you. I've been meeting quite a few students lately, which is so exciting for me through all of your project work on your great Naval Orange race boats. I bump into you all in the halls and the TI lab. And, if you see me, just don't be afraid to just pull me over or wave me down and ask for help. If I can't help you immediately, I can connect you with someone who can help you. So I do hope that all of your efforts are going well with your boats. And today's topic is one of my favorites. It's the sustainable engineering, basically. And I have just a passion discussing about this topic. It's something that we do cover in the environmental engineering courses that I discuss. But part of the reason that I talk about it today is that I just never know when you may hear about this topic. So sustainable development, basically, it's a very broad concept. It's very interdisciplinary, and there's many, many interpretations, hundreds literally of interpretations that you can hear that define what sustainable development is. However, there is one definition in particular that has kind of withstood the test of time. It was developed back in 1987, which was quite a while ago for all of you. That was actually a very fun time of life for me personally. And it is when, part of the reason I became an environmental engineer is because at that time in America, it was like an awakening, and everyone realized the importance of protecting our world for future generations. And they didn't just talk about it. Congress funded initiatives. Everything kind of takes money nowadays, right? And the degree and the career of environmental engineering was basically coming to quite a peak and expansion. But sustainable development, again, this definition, meeting the needs of the present generations without compromising the ability of the future generations to meet their own needs. So you can see it was just kind of a very enlightening time in America and in the world. So sustainability, in the chat, I know I can't meet with you guys one-on-one. I really enjoyed last week's industry panel where people were interacting and asking questions. I loved it. But in the chat, maybe go ahead and put what you do, what choices you make on a daily basis that promote sustainability and promote kind of green initiatives. And you're basically less wasteful, right? That's what we're talking about here. So go ahead and put that in the chat. I'd love to see what y'all have to say. I'm sure a lot of things will be repetitive, but that's okay. What's wonderful is that I can ask you this question and all of you will just have an idea, at least in your head, even if you don't put it in the chat, of what you do to promote sustainability in your daily lifestyle. Sustainable choices, they can be both personal choices. As I mentioned, put in the chat what you all do to be green, so to speak. But they can also be professional choices. And so really more today, what I want to talk about, the personal choices of, yes, transportation, how you get to and from places. You can ride a bike, you can take the bus, you can take a train. The purchases that you make. A lot of people do purchase one product over another product if the first product is reusable, recyclable, and was really built and designed in a more green mindset. And then, of course, reusing and recycling things. So on a personal side, I know a lot of us do that nowadays. It's in our blood, in our psyche, which is great. But it's the professional choices that I really want to focus on today and talk to all of you about. As a design or managing engineer, you will eventually have the ability to make sustainable choices. And today's topic is really to kind of plant that seed in your head that, yeah, I'm the manager, I'm directing this portion of a project. Maybe I have that ability to make a sustainable choice. And we're going to talk about how you evaluate that and look at that. So one of the most important things in the realm of sustainable development is it's called the 3 pillars of sustainability. And the goal is to be innovative in each of these 3 pillars, each of these 3 areas. And they are the social aspects, communities, the environmental impacts, most often, the environmental impacts of what a project or what development will do. And then, of course, the economic factor, because we are very much a capitalistic society, right? Businesses make money, people make money. Businesses pay taxes, people pay taxes. Infrastructure is built, and we're, living well because of that. And then as a result, when you talk about the 3 pillars of sustainability, you have to be realistic and talk about the economic impacts as well. Another fun phrase that I like to use to remember the 3 pillars are people, society, planet, the environment, and profit, the economic aspect. So, people, planet, profit, those are the 3 pillars. And only when those 3 pillars are in balance have you attained basically a sustainable concept or a sustainable project. And that would be in the Venn diagram there, that little tiny place in the middle. And sometimes it's really hard to get to that center point. So again, the 3 pillars: economic, making effective investments, ones that promote, promote industries and technologies that have a sustainable mindset or sustainable goals. Creating wealth. I mean, again, we are in a capitalistic society. The companies make money. They employ the people who make money. We all pay taxes, give back to our government. So we have safe drinking water, wastewater treatment systems, wonderful roads to drive on. So the wealth creation is also a very important aspect of sustainability. And then job opportunities. Again, companies create these jobs, and it just generates this wonderful kind of a cyclical economic circle, so to speak. So regarding the environment, yes, taking care of natural systems, monitoring public health, having clean water, clean air. I mean, these are things that, especially in the United States, we tend to take for granted. It's just not the case as you travel around the world. Maintaining biodiversity is very important as well. We often hear about, oh, don't destroy the rainforests. Well, it's not just because they're beautiful, but they are also a huge part of, the eco balance of our world. For all we know, the cure for cancer is in some plant down in the rainforest area. If we pave over everything, it's gone, right? So again, maintaining biodiversity is so important. And then, utilizing wisely natural resources. So that's kind of the environmental side of the 3 pillars. And then the social side is just as important as well. Health and safety of our citizens, justice, maintaining justice and having laws. A lawless society is not fun. And, so maintaining justice and laws is important. Having people employed, having people contribute to society, that feeling of, of independence, and when people are employed and they're generating income and taking care of themselves or their families, it's a very uplifting, obviously, experience. And then again, just developing that sense of community, all important social aspects. So when real quickly on the slide, you see the phrase triple bottom line. Well, that's really what it is. When you talk about business, if you've watched movies and whatnot, and you are aware of, how our capitalist society works, you've heard of the bottom line. And the bottom line is that a company makes money, because if a company doesn't make money, they can't stay in business, they can't employ people, and, again, businesses go under. It causes a lot of problems. So the bottom line was always, we got to make money. But the triple bottom line, that really is more of a business per se that looks at the entirety of the business. It looks at those 3 pillars of sustainability. It considers the people, the planet, and then making a profit to make sure they can stay in business and employ people. So again, why are we talking about this now? You're a bunch of freshman engineering students, right? I am not really sure in what classes an aerospace engineer is going to hear about sustainable engineering. I don't know. And that's why we're talking about it now. Because in this course, we have all of the engineering majors. And again, I just want to make sure that you all realize that here at UCF, in college, you can make sustainable choices, right? I'm going to show an example real quickly about how in the clubs that you're in and the projects that you're working on, you can choose to make sustainable choices. Those of you with the boats that have the, the big 2-liter bottles floating your your electronics and making and comprising your boat, that's fine. That's a sustainable choice that you've made. It's also a good economic choice, right? It was pretty cheap. So again, I want you to realize all the different majors out here, the civils, environmentals, construction engineers, you will hear more about sustainable engineering through your coursework. But everybody else, I'm really not sure. And that's why we're talking about it today. And I want to encourage you to practice like you're going to play. All right. And the example I'm going to use is right here. With regard to green engineering, the UCF, American Society of Civil Engineers Club, created a concrete canoe and participated in the concrete canoe competition. They had to design, build, and race, kind of like your boats, I guess, a concrete canoe, and yes, they do float. And part of the overall judging of UCF's team against other teams throughout the entire southeastern U.S., I think it was like 22 teams, they had to implement the 3 pillars of sustainability in their project. And so with regard to the social aspect, they conducted workshops for all new members so they can learn. And what's great about that is that if they teach young people, hey, here's what you need to do to be a contributing partner in this concrete canoe effort, we're going to teach you. And so young people learn, and when the seniors graduate, hey, the young people are here, they've learned, they've done things. And it continues. It's a sustainable effort on ASCE's part. The economic part, well, they spent just over 10% less of what they were budgeting, which is great. They were able to use some recycled materials in their efforts as well. And the materials they didn't use, they're going to save and reuse and recycle for next year as well. And then with regard to environmental, they made a sustainable choice of using fly ash and slag cement, old cement, used cement, into the concrete mix because it's less environmentally it's less environmentally impactful, I guess. It has a better impact, reusing and recycling versus just using brand new, the type IL, whatever, Portland cement, okay? So bottom line is they made a sustainable choice in the actual canoe mix, and that was a great aspect of their project. Here are some photos of the team, and I am so excited. I'm the junior faculty advisor for ASCE. I'm so proud of these students, but they are the Southeast Symposium champions for this year. UCF has never won. This is the first time that UCF has won the overall concrete canoe competition, and they are going to the national competition in June for the first time ever. So really proud of this team of Knights. And for those of you who might be interested in ASCE and in these competitions, join, because like I said, they're going to teach you. You are going to learn and become an integral part of the team. So again, just some photos of what they did to get to where they were. You can see Aniket, their canoe had the theme of Egypt, where really transportation was pretty much canoes, right? Back in the day, so to speak. And a very wonderful and historical theme that they used, and their canoe is absolutely beautiful. So again, congratulations to ASCE. We're really proud of them. But most of all, really proud that you implemented those 3 pillars of sustainability. So sustainable design nowadays, it goes beyond what I grew up with, which was, okay, I think I'm just going to recycle, reuse, repurpose. It's more than that. Nowadays, companies are designing products that have not only societal benefits, meaning they can be reused rather than put in a landfill per se, but they're viable for business. Business has realized that, wait, if we reuse, recycle, so to speak, we are going to save money. My favorite project back when I was working as a project engineer right out of college was the reclamation, the reclaimed water facilities that we were designing back in the day. And to me, reclaimed water, a lot of you irrigate your yards with it nowadays. It is the ultimate in reusing and recycling and sustainability, because we literally, with reclamation, we take wastewater, poop water, and turn it into water that's functional and is used to irrigate crops, grass, all kinds of areas. And that happened only because, as a nation, Congress and the Senate came together and said, you know what, we have to stop dumping wastewater into our lakes, oceans, rivers, streams. And they put the money behind it. So they had the Clean Water Act, and they poured billions and billions of dollars into stopping ruining basically our waterways. There was a time back in the 70s and 80s, there were some rivers and whatnot throughout the U.S., especially industrial areas. You could drop a match and the water would pretty much ignite on fire. Really bad situation. So kudos to America for realizing what was going on and pouring billions of dollars into reclamation. And I personally worked on projects, reclaimed water projects, within Orange County. And initially it was very unpopular. You know, people were really scared. They were like, wait a second, you're gonna spray this wastewater on the citrus that me and my kids are gonna eat. You're gonna spray the golf courses that my husband or my family are gonna play golf on. I'm not really comfortable with this. And so there was a fear of the unknown and a distrust of government officials. And part of my job when I was working, designing these facilities, I did also help with those community efforts of just educating people. And I did enjoy that very much. So we had to overcome the public's fear, basically, with transparency and with facts and data, because we had to gain the public's trust in order to implement these reclaimed water facilities. And so again, it used to be we literally would take wastewater from the sewers and just dump it into the rivers, lakes, streams, and oceans. You know, the theme was the solution to pollution is dilution. And not a good plan, not a good way to do things. So again, what I love about reclaimed water is we took a literal waste and it's now a resource. Your parents may even pay a fee now to use reclaimed water. Back in the day, we couldn't give it away. But now people literally pay for reclaimed water to use to irrigate their yards and whatnot. And back in the day, we would take fresh water, potable water, and use that. That's just not a wise usage of drinking water, right? So pretty cool stuff there. And another ironic story that I have to just tell you about real quickly was the space shuttle program. My husband was the chief engineer for the space shuttle program the last 5 years of the program. And you know, he would joke when I would say, oh, I'm going to talk about sustainable engineering today. And his attitude, because he's an engineer who needs to launch people into space safely, right? That's all he thinks about. He said, I don't even have time to think about sustainability. And I kind of giggled because I said, you know, that program you're running is the sustainable program. And he's like, oh yeah, I guess so. But the bottom line is that, you know, they use the solid rocket boosters almost 300 times, you know. They were launched and they reused these boosters, they reused parts, they refurbished the shuttles themselves. It was the beginning of what we see now, which is absolutely incredible. My husband, ironically, is now the chief engineer for the Commercial Crew Program, which is an unbelievably sustainable project, right? Look at the numbers on this slide. 634 launches, almost 600 booster landings, and then, you know, about 550 booster reflights. That's incredible. And again, when you operate based on, you know, profit, planet, people, what's happening is incredible. SpaceX is a company that employs many people. They're becoming very wealthy at what they do. They're becoming wealthy because they reuse and recycle so many aspects of their launch vehicles. And that's, I mean, and that of course protects the planet because they're not having to go pull out more minerals from our Earth, right? They're reusing and recycling what they have. So kudos to SpaceX and all the other incredible companies out there that are doing these things. So 80% of a product, the environmental impact is made during product development. Here's where you all can start making a difference, right? As an engineer, the material selection, the supplier selection, the manufacturing processes themselves, the efficiency of the product, and thinking about the product's disposal even before you build the product, right? These are all different aspects of sustainability that you as engineers can make the choice. You make these choices. What are you going to select? You're going to decide what goes into this product. How is it going to be built? How it's going to operate? And then how is it going to be disposed of or reused on the end, on the flip side? So with that being said, look at what we call the product life cycle. The product life cycle looks at the beginning, the raw materials that are pulled out of the earth and are basically transformed to create products that society purchases and uses. And all along this product life cycle, engineers are making decisions. And that's where, as an engineer, as a project manager, you can in the future make that decision, a sustainable one or not, right? So the goal is to make as many sustainable choices around and throughout this entire product life cycle, right? From raw material extraction all the way through recovery, right? So green chemistry, just want to make you familiar with that phrase. There's the 12 principles of green chemistry that the EPA has identified. A green chemist is someone who's basically going to use, when given the choice, right, a non-toxic or less detrimental chemical versus something that is dangerous to society, dangerous to humans, right? Maybe it's cheaper, right? Maybe it's cheaper, but it's also horrible, toxic, dangerous. So then the choice would be, okay, think about society and the safety factor. You got to think about the money. So if you're going to spend more money on the safer material, find somewhere else in the process that you can save money to offset the sustainable choice that you're going to make. Same thing with green engineering. EPA has identified, EPA being the U.S. Environmental Protection Agency, the 12 principles of green engineering. You know, again, you can make different choices throughout product development, and you can make sustainable choices. Same with building and construction. Everything from siting, design, construction, operation, maintenance, renovation, demolition. All of these choices along the way can be made from a sustainable mindset if you just slow down and do it. Homes nowadays, I'll use this as a quick example, they use, you know, lower flow flush toilets. Well, you're saving water, right? Just as an example, when we were in Korea, one of the things I noticed everywhere I went, you know, we tend to use potable water, believe it or not, in our toilet systems. Again, we reuse the wastewater that comes out, but in other countries, and South Korea was an example, when I traveled, I saw that they were using not potable water in their actual, you know, toilet systems and whatnot. So really, that's even a step above in the sustainability world than we do here in America. Improving indoor air quality using sustainable products, and then reducing waste through construction process, all can lead to green homes. Here are just kind of a couple examples about the design of our buildings that can be utilized to promote promote clean air, and again, you know, promote insulation and whatnot, green roofs, as I'm going to show you in the next slide. You know, all of these things are offsetting our energy needs, which is great. Look here at this example, light shelves on a building exterior in Denver. You see on the left, when you're looking, you see that the one room is dark, but when you put in those light shelves, it just illuminates the office more. And really, I mean, any little bit of natural light. I have a tiny bit in my office here at UCF, and I love it. And it really makes a difference for me. This is a company I became aware of, Sasaki Design. They're headquartered out of Boston. But pretty much what they do is design buildings and industrial areas and campuses, believe it or not, and public spaces that are they have in the infrastructure sustainability built in. You've got, here you see the green roofs. They've got those light shelves, those open, bright, letting sunlight in. And another example from Sasaki, another project that they did, an urban renewal project. This looks, right, like a really pretty, beautiful park where I would love to have a cup of coffee, right, and just enjoy looking and being there. It's a beautiful space, but it also is designed to capture stormwater. The concrete in the area is what's called a permeable concrete, so it acts as a stormwater control system in and of itself. The water that is captured from rain, the rainwater is captured, is reused and recycled. So again, what is a beautiful outdoor space is really an amazing engineering project in and of itself. And so again, I hope I didn't talk too long, but I just want you all to know that as engineers, whether it be a construction engineer, civil, environmental, aerospace, you all can make sustainable choices. And remember that phrase, people, planet, profit, the 3 pillars of sustainability. If you walk away today knowing that, people, planet, profit can be achieved, and you as engineers can make those choices, then that's really what I wanted you to learn today. Have a great day, everybody.
Hi everyone, and welcome back. We're going to be going over some things to look for in next week. So right now we are on week 12. We're going to be moving into week 13. That means that it's the last week before race day. And speaking of race day, on this week right here, for the 14th and the 15th, Tuesday and Wednesday, are going to be your test days at the Reflecting Pond. This is going to run from 8 a.m. to 8 p.m. and there will be at least one TA there to help you out. You can go during any of this time, and you can also review this in your lab next week. Another thing for next week is you can sometime at the end of this week, hopefully today, in your lab announcements, you will see the time of your heat. This is so you can try and get a hold of your professors to see if you need to get out of lab, or class, whatever it may be. So make sure you are looking in your lab announcements for what time your heat will be on Friday the 17th. So please look out for that. And then one final thing for me is that next week in lab, you're going to be going all over what you have to look forward to for race day. And this also includes deliverables, which includes your final report, your final peer evaluation, and your competition race day form, which has to be completely printed out with a physical piece of paper printed, or else we're not going to take it from you. So we'll be going all over this next week in lab, so make sure you're looking out for that, but this is just like what to look out for.
Okay, and then a few final announcements here. Number 1 being today is your withdrawal deadline for your classes. So please make sure to look in your grades in Canvas, make sure that everything's looking good, that you feel like you're going to pass your classes and do well, because today is the last day you will be able to withdraw from them. Another thing is that we're going to be posting wiring diagrams ahead of the Great Naval Orange Race to make sure everyone's plugging their electronics in correctly. You can also check your announcements in lecture and in lab. We're going to post those for you. And then finally, if you're ever in the TI lab, we've got some graphics in there for you to reference as well. So if there's ever any uncertainty when you're plugging things in, you can always check those, make sure that you know what you're doing before you accidentally fry anything. Speaking of the TI lab, we definitely want to emphasize the etiquette of working in the TI lab. They're being very gracious and helping us, but we want to make sure that we are being respectful of their time and their space as well. So number 1, if you're in there, please make sure you clean up after yourself. That's just common courtesy. Another thing, if you're working with any electronics, don't leave them plugged in if you're not going to monitor them, especially anything that generates heat, like a hot glue gun or a soldering iron. In addition, if you're planning on laser cutting in the TI lab, make sure you're bringing material to laser cut and that you've also sent in your DXF file because you can't just show up empty-handed for that. What else? If you have a prop shaft that you need to drill out the coupler for in order to fit on your motor shaft, you can bring that to the machine shop and they will help you there. And then finally, the TI lab is only going to offer support with programming and electronics for people who are using the MSP microcontrollers. If you're using anything else like an Arduino, then unfortunately you're going to have to come to me primarily, or any of your TAs who offer help with Arduino. the TI Lab is not going to be helping with that. So only the supported microcontrollers for them. That's it for this week, and thank you for your attention. Hey everyone, welcome back to this week's segment of TA Spotlight. I'm here in the TA office with TAs Micah and Brooke.
Hello everyone, my name is Micah. I'm a junior here at UCF. I'm studying mechanical engineering, and I've got a minor in material sciences.
My name is Brooke Reynolds. I'm also a junior in mechanical engineering, and I have a minor in environmental studies.
And thank you guys for speaking with me today. This week in lecture, we heard from Ms. Sullivan about sustainability in engineering, which I think is a super important topic that we really can't emphasize enough. And unfortunately, something that I feel like we don't necessarily cover later on in our curriculum. So what does that really mean to you guys, sustainability in engineering?
Yeah, I mean, I see this popping up in little ways in like material sciences and getting farther into those classes. Just things about like understanding like failure modes in different mechanisms and in different materials, and like understanding those better. What that really allows us to do is like improve the lifetime of components. And anytime we're able to like improve the lifetime of any material we're using, that really helps us to create like more sustainable structures, more sustainable mechanisms. Then I think the other thing would be like just the idea of what's called like a minimum mass design, which is where you're trying to use like the minimum amount of material that you need just to achieve whatever function you need to meet. So that would be where I would see it in like my material sciences minor.
Yeah, that makes a lot of sense.
Yeah, and then I think another really important part of sustainability is, considering kind of like in line with the longevity of a material and how long your structure is going to last. When you're building it, the impact it has on the environment around you and what kind of resources you're using, and how that's going to impact things even like really far down the line, not just like for the next generation but for several generations after that, and making sure that the changes we make in the world are things that are sustainable.
So as we're talking about sustainability in engineering, I know it's a pretty relevant topic for me personally because a lot of my research is in renewable energy with wind turbines, which is something I care about a lot. Sustainability in engineering, but also as engineers, we can be sustainable, like you mentioned, with the structure and the materials themselves. And specifically as a controls engineer or in a controls lab, we focus on the like software and the control and the coding to make it last longer itself. So the way that you turn the blades of the wind turbine and all these different things can make the wind turbine itself last longer. And then you're not worrying so much about, these fiberglass and like all these manufacturing materials. So it's good for the economy and it's good for the environment. I think that's like a really cool overlap for sustainability personally. But I wanted to ask, have you guys ever studied sustainability in engineering, or has it come up like personally in your projects?
Yeah. For me, like similar to what you were sharing, like about in the research that you're doing, like in the material sciences research lab that I'm in right now, one of the projects we're actually working on is working to rebuild what's called a rotating bending machine. Basically, just how that works is you have a little specimen, and you just rotate it really fast with a certain load on it to create a stress in the specimen. And then you just see how many cycles can I rotate this before it fails.
Yeah.
And that really helps you to understand like the failure mode of that specimen, like how long can I get this specimen to last before it fails. And you can like apply that knowledge to any sort of like rotating machinery, so you can get like all your like rotating shafts in like a car to last longer, for example. And that's really a great way to create like more sustainable products, just that they're going to last a little bit longer, right?
Yeah, that's awesome.
Yeah. Well, I don't have too much, practical experience, but, I do have the environmental studies minor, so I've done a lot of theoretical and like reading on sustainability across a wide range of topics. And something in engineering that I think people don't often consider or think of when they think about, like what you're doing as an engineer. Most people think of like building or tinkering. But another part of engineering is, the business side and like interacting with other people and communities, and not only like the people around you but the environment around you, and sustainability is a big part of that. One example is like if you build a factory somewhere and you're trying to pick where to put it, it's easy to say like, let's just go with the cheapest option. But money's not the only factor to consider. If I pick the cheapest option and it's in an area where it's going to have a lot of negative repercussions, or it's going to really degrade the area around it, and there happens to be a lot of people in that area or a lot of water, then those impacts are going to not only limit your ability to have resources in the future for future projects and endeavors, but it'll also cause damage to your reputation and your relationship with the communities and people around you. And then not so much business related. Another example is since we're in Florida, you might or might not have heard of biomagnification, or as it's more colloquially called, like algae blooms, which is when you have phosphorus or nitrogen runoff into water, and that causes the algae to overgrow, and then it takes up all the oxygen, and basically all the fish and animals living in that body of water die because they don't have any oxygen. But so there's things like that, consequences that you just might not have considered or thought about if you're only focused on one thing when you're planning out a project. And part of sustainability is also thinking about the broader, more long-term picture, and how the choices that you make day to day in projects and management and material location, things like that, how those are going to have spread out and maybe unforeseen impacts on the broader world and communities around you.
That's a great point. Well, this was a great and I feel really important conversation on sustainability in engineering. I really appreciate your time. Thank you both for sharing your insights. And I'm going to see you guys next week. And now let's hear from one of our RSOs in the Club Spotlight.
Hi, my name is Kathleen Cravens, and I am UCF's RoboSub lead. RoboSub is an international student competition. Student teams from around the world design and build robotic submarines, otherwise known as autonomous underwater vehicles, AUVs. The behaviors demonstrated by these experimental AUVs mimics those of real-world systems, currently deployed around the world for underwater exploration, seafloor mapping, and sonar localization, amongst many others. To manage this complexity, we operate like a professional engineering firm. We're split into 3 specialized subsystems: electrical, mechanical, and software. Our success depends on how well these systems integrate into a single functional unit. The electrical team manages the sub's power and connectivity. We design custom circuit boards that act as the sub's central hub, ensuring every part gets the right amount of power to run safely. We also connect the sensors that allow the sub to hear and move underwater, making sure all the hardware communicates perfectly with the main computer. The mechanical team is responsible for the physical architecture. This includes designing pressure-rated hulls and modular chassis systems that can withstand underwater environments. We use CAD for design, as well as CNC machining and 3D printing to build everything from the main frame to the systems used for mission tasks, such as the torpedo launchers, robotic manipulators, and marker droppers. The software team provides the quote-unquote intelligence. We use the Robot Operating System, ROS, to build our autonomy stack. This involves everything from you only look once, or YOLO-based computer vision for identifying targets, to simultaneous localization and mapping, or SLAM, for mapping out unknown environments. Essentially, we fuse data from all sensors to ensure the sub knows exactly where it is and what to do next. To wrap things up, Aquanight's AUV is a premier opportunity to build your engineering career. We offer hands-on experience in custom hardware, manufacturing, and artificial intelligence. Please scan the QR code to access our Instagram and Discord. Discord meetings are on Tuesdays at 6 p.m., and in-person meetings are on Fridays at 4 p.m. in Engineering 2, Room 203. We look forward to seeing what unique perspective and skills you'll bring to our team. Thank you.